In this video, we will talk about type interference with var. Prior to Java 10, you define variable with a primitive or object type, such as string name is equal to Mike, local datetime is equal to local datetime.now. Starting with Java 10, you can drop the explicit type depending whether compiler can infer the type. The important thing over here is that compiler should be able to infer the type. For example, in this case, we have assigned name is equal to Mike and define the type as var. In this case, compiler can infer that Mike is of type string, so this statement is fine. In this case, var datetime is equal to local datetime.now. Compiler can infer from the class name that this is of type local datetime, so this statement is also fine. A local variable of type var must be initialized with this declaration. Compiler must be able to infer the type of variable, so a variable with null value won't compile. So in this case, you must initialize first this variable, because if you don't initialize this, then compiler won't infer that what type of variable is this. So in this case, you will get a compiler error. Now let's code some of the examples of type interference with var in IntelliJ. Let's create a new package and new and then package, and the package name is com.modronjava.java improvements. And inside this package, let's create a new class, and the class name is type interference example. So let's first create public static void main psvm, and the first example is with string. So in this case, string name is equal to Mike. This is how we used to do it before Java 10, and with Java 10 you can define var name is equal to Mike. Let me comment this out, and then var name is equal to Mike. Now let's print it out. Let's run this example. And you can see that it printed out name is equal to Mike. Now let's look into few other examples. Let's take an example of datetime. So var datetime is equal to local datetime.now. This is equivalent to local datetime is equal to local datetime dot now. And let's print it out. Now let's look at an example of hash map. So before Java 10, we used to do that hash map and let's define a hash map of type integer and string map is equal to new hash map. Now you can define variable map is equal to new hash map, or in this case let's make it map1 is equal to new hash map. And here what we can do is that we can define the type for the arguments, like for example in this case integer and a string, and this is fine. Now let's look at the integer array. So for example, you define integer array numbers before Java 10 is equal to 1, 2, 3, 4, 5. Now if you do var of numbers is equal to 1, 2, 3, 4 and 5, compiler won't be able to infer that what type of argument is this one. So in this case, it won't compile. So what we need to do in this case, array initializer is not allowed here. So in this case, what we can do is that if you want to define this, number one, then infer type integer array and new integer array, and that should be fine now. So the important thing over here is that compiler should be able to infer the type. In this case, in the previous case, when we don't have the new integer array, then compiler was unable to infer the type, and that's why I was given the compile time error. Now let's look at the example of list. So in this case, we have, let's say, list of string and names is equal to new array list and then afterward we add names.add Syed names.add and Mike. So we are adding two names to this one, and let's print out names dot and let's print out the names. Now if we change this list to var, then what will happen is that var does not have this type defined inside this diamond operator. In this case, what will happen is that if we define a variable of names1 is equal to new array list, this is perfectly fine. But then now, as we don't have the type defined, it will put the type safety of generic at risk. For example, in this case, we can add anything to over here. So names.add and Gene names.add 1.0001 names1.add and names1.add 1. So you can add any primitive or object type in this array list, and it will take it, because if you try to add, for example, in this case, names.add, let's say 1, then you get a compile time error provided integer required string, because we have this type defined for the list which is of type string. But in this case, when you have the variable defined, it cannot infer that the type for this names1 is string. So in this case, either you can define the type over here, and that is fine, and then we will get error over here. But if you don't define the type over here, then in this case you can add any object or primitive type inside the list. So let's print this out. Now let's run this example. So you can see that when we print it out here, names, then Syed Mike, and then here names 1 is equal to Gene 1.001 and 1. Now let's look at another example of list of integers. So you can define a list of integers using var integers is equal to list.of, and this is of mutable type. So 1, 2, 3, 4, and 5. And integers dot for each and integers dot for each and system dot out colon println. So this is of type list with factory method of. So now let's look at example of integer type. Like for example, integer num is equal to 99999. So you have integer type and you cannot assign this to a long number to the integer. So if you even infer L over here, then it won't work. Now let's take the same example over here with var. Var num is equal to 99999. Same problem over here. But when you infer type that this is of long, then var assumes that this is of long and it automatically takes this variable. And then for example, if I do dot 99999, then make it d, and this variable is of type double now. Now let's look into the example of division. So for example, when integer values are used as operand in the division, the result is not a decimal number but an integer value. So this is, we already have seen, like this is the generic behavior, this is the normal behavior of Java, that when you have integer operands, then the result will be always be integer. For example, in this case, even if we have result is equal to 9 divided by 2, then the result here will be 4. So let's print this out, out p, and then let's run this. And you can see that result is equal to 4 because the decimal numbers are dropped as we have the arguments as integer. Now if you have the same and then append 0.0 or convert any of those numbers to double, then the result will be 4.5. And so you can see that result 1 is equal to 4.5. Or you can also do this with result 1 is equal to, let's use another example, 11d divided by 2d. So if you infer that with d, then it means that it's a double value. And then let's print out result 1. So you can see that result is in decimal value 5.5. We also have done the same thing. We have also have done an additional thing over here. We have assigned the, you can reassign the variable with another value, and that is fine. So this is another case where you can reassign the variable values just like any other primitive or object type. You can also use var to pass on the value as an argument. For example, in this case, let's create a small static method void print ln print a string, which takes an argument of a string to print. And here we're just printing out. And let's define a variable idiom of the day is equal to a blessing in disguise. And let's call this method print string and idiom of the day. So you can pass this variable as just like the normal variable to a method. Let's run this. A blessing in disguise to print. An important thing to note over here is that variable, the usage of var is limited to local variables. You cannot define a variable which is a class level variable with var. For example, if I create a var number 5 is equal to 5, then it will give me compile time error. Cannot resolve simple var. So var is only limited to local variables, initializers, and also constructors. Constructors you can define or also with the loops and switch statements.